What's going on, guys? Tom here, and in today's video I'm going to be teaching you how to create a Raycast weapon system in Godot, complete with clip size, firing rate and reloading. If you haven't already followed part 1 of this Make an FPS in Godot series, I'll leave the link in the description below, so you can go back and watch that first. Alternatively, you can grab the source code for everything that we covered in part 1 in the description below as well. With that being said, let's get started. Okay, so as always, the first thing we're going to do is we're going to launch Godot. The FPS Tutorial 1 project that we had from the first part of this tutorial, you should see it here. You can click on that and press edit. Now, while that's loading, if you didn't follow through with part 1 of this tutorial series, you can grab the source code from the description below. You could also just go back and watch that tutorial, follow along, and then you'll be at the exact same position that we're at right now, whereby you have a player in the middle of the screen, which is this capsule collider here. It's got a camera pointing out roughly where the head would be, and we have a ground object here which has a collider on it, which allows our player to land on it. If we press play, you can see that we have full control with our mouse of looking up, down, left and right. We can use W, A, S and D to move forward, backwards, left and right. We can also press space to jump, and you'll also notice that we have gravity in place as well. So that's where we left off in part 1. Like I say, go and grab the source code for that, or follow along, catch us up, and then come back to this video. Okay, so what we're going to do now is we're going to create a Raycast weapon system. Now, in order to do that, we're actually going to have to do a couple of things. One being add a Raycast to the player, and 2, write some scripts to interact with that Raycast to determine whether or not the Raycast actually collided with anything when we fired the weapon. So what we're going to do is we're going to come into our player object and click into the player's scene. And now we want to click this camera icon here and right click on it, add a child node, and we're going to add a Raycast to the camera. Now the reason we're adding a Raycast to the camera is we want the Raycast to fire out directly from where the camera is, directly to where the camera is facing. So that's the exact center of the player's viewport. Now if we add this Raycast to the camera as a child node, it's going to be in that exact position, which is great. So we're going to click on the Raycast, and on the right hand side you can see that we have a few options here. The first thing we're going to do is click Enabled to make sure that this Raycast is actually going to detect collisions. We're going to keep Exclude Parent on, which means that it's basically going to take its parent node and it's going to exclude that from any collision detection. And we're going to change the Cast2 property. We're going to change Y to 0, and we're going to change Z to -100. Now you'll notice here that this faint line has appeared directly in the center of the camera, and it's shooting off into the horizon there. Pretty large distance. Now that is effectively the distance that we are going to check for collisions in. So that is effectively the firing range of the weapon that we create. We can modify that obviously by coming into the Z-axis again and changing it to -10. Obviously that's a little bit short for a projectile weapon, so we're going to change that back to -100. You could modify this with scripts. If you had a weapon that say needed a larger firing range or one that had a shorter range, such as a shotgun, then you could come in and you could tweak that, or you could have it done directly via the script of the weapon itself. The next thing we're going to do is we are going to create a script which serves as the basis for all weapons. Now I said we're going to create a Raycast weapon system. What I mean by that is we're going to create a generic script that is a Raycast weapon, which you're going to be able to then inherit from in GDScript to modify some of its parameters, such as its firing rate, its clip size, and its reload time. To do that, we're going to right click on the player, we're going to add a child node, and this time it's just going to be a node. If we scroll up to the top here, choose a node and press create. We don't really care where this is in 3D space. It doesn't actually need to be in 3D space at all. So we're just going to create it as the base node object. We're going to right click, rename it, and we're going to call it weapon. Now we're going to right click on this weapon, attach a script, leave everything as default. We're going to create this weapon.gd script, press create. What I'm going to do is I'm going to delete all of this. And now we're going to set up some variables for the different kinds of parameters that our weapon can actually have. They're going to be export var fire rate, and we're going to say that for default, firing rate between each shot is going to be 0.5 of a second, so half a second. Next, we're going to export a variable called clip size. For this, I'm just going to choose 5. We're going to export a variable called reload rate, and that's going to be the time it takes between firing the weapon to empty and reloading it to full clip size again. So for this, I'm going to say 1 second. Okay, the next thing we're going to do is we're going to keep track of what our current ammunition is. And to do that, we're going to say var current ammo equals, and we're just going to initialize this to whatever our clip size was, so clip size. The next thing we need to do is we need to determine whether or not the user has actually fired the weapon. Now, if you followed the previous tutorial, you'll know that to modify the project input map, we can go project, project settings, input map, and then we can add a new action here. So what we're going to do is we're going to say primary fire. We're going to add that. Click the little add button to the right hand side of it, choose mouse button, and just leave it as default, which is device 0 left button. Press add, and now we can close that. So we're going to create the process function. So func underscore process, and here we're going to say if input.is action just pressed primary fire, then effectively here what we're going to do is we're going to fire the weapon. So there's a few things we need to do to determine whether or not we can fire. First of all, we need to check whether or not we have any ammunition. We also need to check whether or not the firing rate time has elapsed. So we're going to need to create sort of a little helper function here, or a boolean that can tell us whether or not we're allowed to fire. Now I'm just going to specify a boolean variable here called var can underscore fire equals true, which means that this variable is going to determine whether or not we're allowed to fire, and initially we're going to say yes, the player can fire the weapon. So we're going to add this to the end of the if statement here. We're going to say and can underscore fire, and we're going to fire the weapon. So here I'm just going to say print fired weapon, and we'll save that. Now we're just going to test this quickly by pressing play. We can look around, we click the left mouse button, and you'll see down here in the output it says fired weapon. You'll notice that we can just click, 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 and it will just say fired weapon over and over again. We don't have that fire rate delay in place. So what we're going to do here is we're going to say, as soon as the user has pressed primary fire, we're going to say CanFire equals false. So they fired the weapon now, they can no longer fire the weapon until this fire rate has elapsed. So let's just put that down just below the print, just so that we know this is the start of where we're firing the weapon. We're saying we can no longer fire. And now what we want to do is elapse that fire rate time. To do that, we're going to say yield create underscore, get underscore tree dot create timer, and this wants to take a time in seconds, so we can pass in fire rate. We can close our brackets there, comma, and now we want to say what event we actually want to wait for, and we want to wait for the timeout. Close the brackets, and now after this point, after this yield statement, it basically means that the fire rate time has elapsed. So that yield statement there is effectively saying, I want to wait before I execute any more code in this function. I want to wait for the fire rate. So we're going to wait for 0.5 seconds, and then we're going to say CanFire equals true. We'll save that. We'll press play again, and we'll just check that that timer is working. So we're just going to keep clicking, and you'll notice that that has slowed down significantly. Just to prove it a bit more easily, we're going to say 2 seconds. Save that, press play. We can fire the weapon, and you'll now notice that there's a 2-second delay between each time we fire the weapon. Cool. Okay, so let's change that back to 0.5. The next thing we need to do is we need to decrement the current clip size. So here we're going to say current ammo minus equals 1. So we're going to reduce 1 from our clip size each time. And now what we need to do now is we need to determine whether or not the player actually has any ammunition before we can fire. So now, before we fire the weapon, we actually want to check whether or not we need to reload or fire the weapon, depending on what their ammunition state is. So just before this print statement, we're going to say if current ammo is greater than 0, then we can do all of this. We can go ahead and we can fire the weapon. Otherwise, what we want to do is we want to reload the weapon. So here we're just going to say, actually we're just going to say else. Then we're effectively going to do the same thing here. We're going to yield a wait, and we're going to reload the weapon. So we're going to say yield, get tree, create timer, reload rate. And after that here, we're going to say current ammo equals clip size. We're also just going to put a print statement in here that says print reloading. And we're going to put another print statement down here that says reload complete. We'll save that, we'll press play. And now if we fire, you'll see that we can fire 5 times and then it starts to reload. And then we can fire our weapon again as soon as the reload is complete. What we do want to do though is we want to check whether or not the player is already reloading. We don't want to let them reload multiple times because that could start to get out of hand. You could start to get some weird race conditions there. So we're going to keep track of whether or not they are currently reloading. To do that, we'll say var reloading equals false. We'll do a check here as well just to see whether or not they are currently reloading. So we'll say if their current ammunition is greater than 0 and they're not reloading, then that's fine. We can fire the weapon, because what we don't want is we don't want the user to start reloading and be firing at the same time. Here we're going to say elif not reloading. Just as we print out our print reloading here, we're going to say reloading equals true. And when we're done reloading, we're going to say reloading equals false. So let me just run you over that just one more time, because I realize that is a little bit confusing. We've added a few extra clauses to our conditional statements here. So we've defined a variable to say whether or not the player is currently reloading. We're checking to see whether or not we have fired the we can fire the weapon and the user has pressed the fire button. If that is the case, then the first thing we do, we check whether or not we have any ammunition left and that we're not currently reloading. So we're not currently reloading the weapon, we have ammunition and the user's pressed the fire button. In that case, we want to fire the weapon. Otherwise, we're saying if we're not currently reloading, so we're not currently reloading and we don't have any ammunition left because this clause has failed, then we're going to reload the weapon. We're going to set reloading to true, which means that all of this is going to not pass the next time the user hits the fire button. They're not going to be able to fire once we're in the process of reloading. It's going to wait for the reload rate. It's going to reset our clip size, our current ammo to our clip size. And then it's going to say, okay, we're no longer reloading. You can carry on and fire the next time that the user presses the button. We're going to press play. And now I want you to watch the output screen again. We're going to fire 5 times. 1, 2, 3, 4, 5. It's going to say we're reloading. As soon as it's done, we can start firing that weapon again. And you'll notice that that is the same. It's consistent every single time. We get 5 shots. We get reload. We wait for a period of 1 second. And then we can fire again at a rate of 0.5 seconds. So now we've got our working weapon raycast system with, the ability to fire, the ability to have a fire rate in between those fires, have a clip size and a reload rate. The next thing we need to do is allow our raycast weapon to actually hit something. In order to do that, we're going to come back to our world and 3D scene, and we're going to add something to the world that just acts as an enemy. To do that, we're going to right click, add a child node. We're going to have a static body. We will right click, we will give it a mesh instance. And we're just going to give it let's give it a sphere, just to differentiate it slightly from the player itself. Now we will right click on this, add a child node. We're going to give it a collision shape. That collision shape, again, is going to be a sphere shape. And we're just going to call this enemy. Now the next thing we're going to want to do is we're going to want to assign this enemy into a group. Now, groups are something that's quite useful in Godot for allowing collision detection to check whether or not the thing that it collided with is actually part of a set of objects, part of a group. To do that, we're going to click on where it says node in the top right. We're going to click on groups, and here we're just going to type a new group, and we're going to call this enemies. Now if we look over on the left hand side here, you can see that next to this enemy it's got this little square icon here, and if you click on that, you'll notice that it says over here that this is part of the enemies group. So this icon here just gives us an indication that this node, as it says there on the tooltip, this node is in a group. Click to show the group stock. So you can do that and you can see what group a particular node is part of. Now we're going to duplicate this enemy just a couple of times. So we will right click and duplicate. We're going to move it just a little bit over here. We'll duplicate it one more time with Control and D. And we will drag it over this way a little bit. And we'll save the scene there. Okay, so we're going to go back into our script and back into weapon. Now what we're going to do here is we're going to create a brand new function. And this function is just going to be called check_collision. And we're going to call that just where we fire the weapon. So just underneath decrementing the current amount of ammo, we're going to say check_collision. We'll save that. And here we're going to say var raycast equals $. We're going to say $head/camera/raycast. And in fact, we can move this to the top here. So we can say onReady var raycast. So we can get a reference to that as soon as the node's loaded. So here, back down here in the check collision, we can say if raycast.is colliding. So if the raycast is currently colliding with something, then what we can do here is we can say if, or let's say var collider equals raycast.get_collider, and then we can say if collider.is in group, we can give it our name, enemies. Then we're just going to print, in fact what we can do is we can say collider.free_q, and we can put print killed, let's just scroll that down, killed collider.name. Save that. Let's run the game. And if we fire now, you'll see we fired the weapon. If we look at the sphere, we can fire. And we're getting an error here. Free Q is incorrect. That should be Q_free. Play that again. Fire the weapon in space. It fires nothing. Click. And now we can see we've killed enemy. Look at this one. Killed enemy 3. Look at this one. Killed enemy 2. Cool. Okay, so that is basically our Raycast weapon system sorted. The next thing we can do now is we can inherit from this weapon, and we can start doing some advanced things here. So what we're going to do is we're going to create a brand new script. Inside our player folder, we can say new script. We're just going to call this pistol. Or actually, let's call it shotgun, just to be a bit more accurate to what we're going to do. So we're going to press create. We're going to come into the shotgun.gd script, delete everything, and then we're going to type extends weapon. Now if we come back into our weapon script, you'll notice that we gave it a class name of weapon. So we can extend that weapon class, and now we have access to everything that the weapon class had itself. So if we come into our weapon node on the left hand side here and change our script from weapon to shotgun, you'll notice that we still have access to a fire rate, we still have a clip size, we still have a reload rate. So I'm going to change the clip size here to 2. I'm going to change our fire rate to 1, and we're going to keep the reload rate the same. We'll save that. And in the shotgun, what we're now going to do is we're going to change the length of that raycast, because we're now firing a shotgun, it needs to be much closer range. This is just a simple example of what you could do with inheritance to create brand new weapons with different functionality. To do that, we're going to say func_ready. And here we're going to do that same thing again, where we get an onReady reference to the raycast. So onReady var raycast equals $/head camera raycast. and we're going to say raycast.cast2 equals, and we're going to give it a brand new vector3. And we're going to call this, we're going to say vector3, 0 on the x, 0 on the y. And actually what we will do is we'll create a new exported variable here, just to show you that we can actually have multiple exported variables depending on our inheritance tree. So we can say export var, and let's say fire underscore range. This time we're going to say 10. I'm going to say here, we're going to say negative fire range. So we will save that. And actually it's given us an error here because on our weapon object we already have access to a raycast variable, which is great. So we can actually delete that, save that. And now if we press the play button, you'll notice that we can fire the weapon, we can fire and we can kill that enemy. But if we try and kill that enemy over there, it's not doing it. And if we get closer and closer and closer, we can now kill the enemy. Basically the range of our raycast, same for this one, we can fire, fire, nothing happening, let's get closer. Oh, we need to reload, fire again, and now it's killed the enemy. So you'll notice there that actually what we did was we took our weapon base script, we inherited from it in a shotgun script, and we made modifications to the raycast length so that it's now a little bit shorter. And you'll notice on the right hand side we've now got this fire range property, which is an extra property that we can modify on this shotgun script. Now you could do this for pistols, shotguns, machine guns. You could create automatic functionality, you could have weapon spread, you could have a whole bunch of different things on different weapon types. Maybe you have a weapon that needs to charge up before it fires, you can do all of that. So this is just a very, very simple example of the power and flexibility you've got by having this base class of a weapon and then inheriting from it to do something slightly different for that weapon. The final thing I want to show you guys is how to create a very, very simple little display of how much ammunition we have. To do that, we're going to come on over to our 3D scene view. We're going to go back into the world. And here what we're going to do is we're going to say, right click on the world, we're going to add a child node, and here we're going to choose a control. We're going to click on that, and this is going to open us up in the 2D scene view. Basically, we're going to now create a little bit of user interface. I'm going to rename this to UI. At the top here, I'm going to press layout, and I'm going to say full rect. Now you'll see that that has expanded this rectangle here to be the full width of the screen. I'm going to add a new child to this, and I'm just going to have a label control. We're going to just size this a little bit. It doesn't need to be precise right now. And we're going to put it at the bottom wide, or so let's actually say bottom right. And here we're just going to give it some text. So we're just going to say ammo, and let's just say 2 out of 2. And now what we're going to do is we're going to go into our player object. We're going to go into the script for the weapon. Now what we're going to do here is we're going to get a reference to that UI label. To do that, we're going to say onReady var ammo label, ammo underscore label equals, and then we're going to say $, open up our speech marks, and to get the root scene, what we're going to do is we're going to type /root. Now if you come back into the world scene, you'll notice that we're in the root, then we're in UI, and then we're in label. So we're going to say root slash, well sorry, we forgot the world, so root slash world slash UI slash label. So this gets us a reference to this ammo label. We're going to save that, and now in the process what we're going to say here is we're just going to update the text of that. So ammo underscore label set text, and now we're going to do some string interpolation. What that means is we're going to create a string where some of the values in it are going to be replaced by variable values. To do that, we're going to say %d slash %d. And then after that, to provide the parameters for those percentage placeholders, we're going to say %, and then we're going to give it an array. We're going to say current, ammo, and clip size. Let's close off that. And now if I press play, you'll notice that we have this label down the bottom right hand side which says 5 out of 2. which there's a little bug there actually, and that is to do with the fact that we're assigning clip size to our current ammo directly there. So what we will do is we'll say that current ammo equals 0, and we'll add a quick ready function here, and here we'll just initialize ammo to be our clip size. Save that, press play again, and now we have 2 out of 2. So that's that problem fixed. You'll notice that if we click, it goes down to 1, we click again, it goes down to 0, and we click one more time, and after a second or two, it reloads back to 2, which is great. That gives us a bit of a visual feedback as to how much ammunition we have and whether or not we're currently reloading. We could go one step further, and we could actually say if we are currently reloading, so if reloading, then we can basically say ammo label.setText, change that to reloading ... Else we can set it to how much ammunition we have, press play again, 2 out of 2, fire, fire again, fire one more time, says reloading, and now we've got 2 out of 2 again. Obviously you could do some fancy stuff with sprites and all sorts of other UI elements there, but that's just to give you a bit of an indication that you can now present some form of indicator as to how much ammo the player has. Final thing that I want to do is I want to break out this reloading script into its own function. So I'm going to create a new function called func reload, and I'm just going to take all of this code here, I'm going to cut it, paste it in there, take out that white space, call this reload. Actually, we're going to do the same for firing. So we're going to say func fire. We're going to cut all of this code out here, paste it into there, clean up some of this white space, call fire there, and we're actually going to get rid of this comment. This just makes it a little bit easier to see what's going on. Finally, we're going to go into our project settings, input map. I'm going to define a new action for reload. I'm going to give it a key of R. And what we're going to say now here is if input.isAction just pressed reload, and we're not currently reloading, then we're just going to call that reload function again, press play, and now you'll notice that I can fire once, and I can press the R key and we start reloading. I can fire twice and press the R key, we start reloading, and that just gives us a little bit more flexibility about when the player can reload their weapon. And that's it for today's tutorial. So today you've learned how to create a weapon system with fire rate, reload rate, and clip size. You've learned how to add some UI elements onto the game so you can give an indication to the player of how much ammunition they have, whether or not they're reloading. And we've also implemented the ability to actually reload at an arbitrary time, just in case the player wants to reload when they're at half clip or whatever. And I've also shown you how to inherit from that base weapon script that we created to make modifications to how a weapon behaves. If you enjoyed this video, please leave a comment down below, give it a like, and consider subscribing if you haven't done already. If you want to see more of these tutorials in the future, please leave a comment as well and let me know what features you'd like to see next. I'm looking for some feedback about where we take this series of tutorials, so I'd really love to hear from you. And with that being said, I'll see you guys next time.